All right, so for chapter 6 on my express train of how do I pass this exam, we talk about Ohm's law. And Ohm's law is where all of your questions are coming from, as well as power. So let's look at the equation that we need in order to use Ohm's law. Ohm's law equation says that current, which is I, and is always in amps, is equal to voltage, which unit is always V, meaning in volts, over resistance. And resistance is R, always in ohms. So the first equation looks like this. I equals V over R, meaning current over volts divided by resistance. Or you can rewrite that to look for volts, which is V equals I times R. So if we go to my handy dandy notebook, I do feel like Blue's Clues, yes. We would say that I is equal to V divided by R. So that's current equals V over R. I can also change this to just give me volts, and volts would be V I times R, right? And then I can also use this to look for R, and R, or resistance, would be V divided by I. So these are the three equations that essentially you will need in order to do any of the problems, knowing that I is always the units that's in amps, R is always the units that's in ohms, and V is always the units that's in volts. And so if I said before, volts, ohms, amps, everything is a plug and chug. You just have to know what you have. So if we go back to your worksheet, we'll start out with question number 1. It says a Walkman, yes, a Walkman, uses a standard 1.5 volt battery. And how much resistance is in the circuit if it uses a current of 0.01 amps? So let's look at what it's asking for. It asks for how much resistance is used. So then we just use the equation for resistance, which is R is equal to V divided by I. So for this particular problem, we are just doing number 1. What is the volts? If I go back, the volts are 1.5. So I have 1.5 volts. And what's the current? Amps. It has a current of 0.1 amps. So 1.5 volts divided by 0.01 amps. And that will give us, take out your handy dandy calculator and get to calculating like I am. So 1.5 divided by 0.01 gives us 150. And because it's resistance, the answer should be in ohms. And if you've never seen an ohm symbol, it looks like an omega sign. All right. And it's just that simple. I know you're like, what? That's all? And yes, that is it. So we figured out how to calculate resistance by using the equation R equals V divided by I. For number 1, the volts were 1.5. The amps was 0.01 amps. Once we did division, it came out to be 150. And we know it was in ohms because we were looking for resistance. All right. So let's move on and look at number 3 because it's asking us a different question than resistance, and I want to try and use all the equations. So number 3 says a 12-volt car battery pushes charge through the headlight circuit resistance of 10 ohms. How much current is passing through the circuit? So it asks us how much current. And so for current, we use I. Amps, current. Current is in amps. So we're going to use the equation for number 3. I is equal to V divided by R. Again, this is math, but all you have to do is look and say, what is this question asking me for? Is it asking me for resistance? I'm going to use this equation. Is it asking me about current? I'm going to use this equation. Is it asking me about volts? I'm going to use this equation. And you'll know which equation to use because you'll be given the information. If it wants resistance, it'll give you what the volts and amps are. If it wants current or it will give you what the volts and resistance are. If it wants voltage, it'll give you what the amps and resistance are. So be smart about it. Don't get overwhelmed. Just say, hey, everything I need is in this question. What equation does it fit into? All right, so looking at number 3, we have current is equal to V over R. And for this one, V was 12 volts for number 3. As you see, I have a 12-volt car battery. And then the resistance was 10 ohms. So 12 divided by 10 ohms. All right, and so we go to our calculator as we did before. 12 divided by 10 will give us 1.2. And we're looking for I, so the answer is amps, or capital A. All right, now I point this out because you'll see 1.2 on the answer key, and you'll say, oh, Dr. Walthall, I got that right, but the Blackboard marked it wrong. Well, no, you marked the one that said 1.2 ohms or 1.2 volts, and you didn't mark the one that said 1.2 amps. So make sure your units match up with what it's asking for. It asks for current, so we gave it the units of current. You can't give me the units of ohms, so I'll just have to tell you, your answer was correct, but it had the wrong units, and I can't give you credit for it. I'll just keep it real. All right, so we move on. Let's try and find us one that asks us for resistance, for voltage. So if we take a look at the sheet, let's see, number 6. Number 6 says a light bulb has a resistance of 5 ohms and a maximum current of 10 amps. How much voltage can be applied before the bulb will break? All right, so it asks us how much voltage. And because we know voltage uses this equation here, V equals I times R. So for number 6, let's write that down. V equals I times R. All right, and so we go back and we look and see what was our amps for I. Had current of 10 amps. So we go 10 amps times the resistance, which was 5 ohms. And without me using a calculator, I can tell you that 10 times 5 is 50. And because I'm dealing and looking for voltage, I know that their units is V or volts. So I've just given you 3 examples for all of the equations for Ohm's law. You have resistance, V equals I over R equals V over I. For current, you have I equals V over R. And then for voltage, you have I times R. And so then I've shown you how to work out each problem. And so you look through this video, and when you get done, do the other ones the same way. Ask yourself, what is it asking me for? Is it asking me for resistance? Is it asking me for current? Or is it asking me for voltage? Use the proper equation, plug and chug. That's all it is. Do not get overwhelmed. All you're doing is putting in the numbers you're already given. You don't have to come up with a number. You don't have to find a number. You just have to put the numbers in that you already have and get the answer. And just make sure that you have the correct units for it. For resistance, the units are always ohms. For current, the units is always amps. And for voltage, the units is always volts. All right. So moving on for the next part of chapter 6 is electrical power. And so electrical power gives us the equation here. So one of the things that your PowerPoint told you was that the unit of power is watt or kilowatt. So we all remember that. We know what a watt is. We've seen it on light bulbs for years and centuries. Although now I cannot tell you anything about a light bulb when I go, because it's not in my normal wattage. Even the scientists has problems when shooting lows. All right. So here we see that electrical power, or watts, is equal to current times voltage. Okay, where 1 watt is equal to 1 amp times volts. So let's look at that. We have power, or P, is equal to current, which is I, times V, which is volts. All right, so power is equal to I times V. Power we know is watts. Current we know is in amps. And V we know is in volts. So again, those are the terms that we'll be looking for when we're doing the question: watts, amps, and volts. So we can rearrange this. This would be our first equation. If we're asked what the power is, if we're given the current, or we're looking for current, that would equal to power over volts. So I just rearranged the equation, saying that I wanted to solve for I. That would give me power divided by volts. And then also, if I just wanted to solve for volts, that would be power divided by I. Yes, so I just did all of this in my head. Ain't God good? So, when we're given and it asks us what's the current, we can use this equation. If it's asking us what a voltage, we can use this equation. So let's go and look. And all of those are there. Good. So we'll first do first question asking us about power. So it says, what is the power when you have a voltage of 120 volts driving a 2 amp current through a device? So we know the equation for power is P equals I times V. So for number one, we'll go ahead and put that. P is equal to I times V. In this particular one, current or amps are 2 amps times the voltage, which was 120 volts. All right, so we were looking at this one where we had 120 volts and 2 amps. So we go back. So what would that answer be? So 2 times 120 is 240. And again, it's power, so the units are going to be watts or W. So 240 watts is your answer for number one. So that's if we're looking for power. Now, if we're looking for current, it says what is the current when a 60 watt lamp is connected to 120 volts. So we use this equation here, which is current I is equal to P over V. And so number two, if the power is 60 watts and the volts is 120 volts, what will the current be? So we'll use our calculator, and 60 divided by 120 equals 0.5. And we see that it's current, so that means that it's amps. I know, my A is funny. So 0.5 amps. So to find current, I is equal to P over V. For number two, it was 60 over 120, and therefore you have 0.5 amps. So we've done one where we found power, another where we've done current, and now we have to find voltage. So let's look at number 4 here. Number 4 says, a part of an electric circuit dissipates energy at 6 watts when it draws a current of 3 amps. What voltage is impressed across it? So, voltage here. And this is number 4. And we say that volts is equal to power over current. Power for this particular one was 6 watts. And the current was 3 amps. And without using a calculator, because I'm so smart, 6 divided by 3 is 2. And because we are talking about volts, it's 2 volts. So now for power, I've shown you how you can manipulate the equation. So you want to have this somewhere in front of you, these 3 equations. P equals I times V, I equals P over V, and V equals P over I. And then I've shown you how to plug and chug the numbers from the problems and come up with your answer. Always remembering that you have to make sure that your units match what you're looking for. Amps for current, watts for power, and volts for voltage. Okay, and that would end chapter 6.